We're verifying that these are inverses. How do you verify if it's an inverse? What should happen to the table? It should perfectly flip over. And if you hadn't been here, you should get a warm-up sheet so you can write this down and put absent on the days you're absent. That way you get 100 today, right? So, anyways, 1 and 5. Yeah. If you were ever absent, you put absent on the day you're absent. No. If it was the next week, I'm talking about on Friday for that week. If you miss a day, put absent. But if it's like weeks later and you need to make those up because you just didn't do them, that's when you get them off YouTube. So all we got to do is look at the table and see if it flips over. So is number 1 a inverse function? What do you think? I hear a no. I hear a, what do you think? And by the way, make sure you're writing the objectives. So why is it no? 1 and 5, 5 and 1? Yeah, it is. Oh, not all of them. So you're talking about 2 and 8? What is this? You see where it's marking? What is this whackness? What'd you do, Jay? Nothing. Well, anyways, 2 and 8, 8 and 3, those are not switched. So that's a no. Does everyone see why? Number 2. What do you think? Yes or no on number 2? Why? Okay, X and Y have been switched on every one of them. That's a yes, sir. Now, 3 and 4. So everyone who's not playing Pokemon on their phone should be, catching Pikachus and stuff. So, on number 3, how do you tell if 2 graphs are inverse? Well, first of all, they're going to be symmetrical across this diagonal line. So everyone see this diagonal line right here? Now, does it look like it's symmetrical across that line? Looks like it. But the way you check for sure, watch this. Here's a point. Here's a point. So this one point, you're going to count the units up to the diagonal line, and then you're going to count the units left to the other function. So this goes up 1, 2, and it goes left 1, 2. Do those numbers match? Yes. Next one. This goes up 1, 2, and it goes left 1, 2. Those are the same, right? And then this one right here, it goes up 1, 2, 3, 4, 5, 6, and then it goes left 1, 2, 3, 4, 5, 6. Do those match? Yes. If it's equal distance to y equals x, the diagonal line, then it's an inverse. You're counting up to y equals x, and you're counting over. Let's try the next one. Now, we have another diagonal line. Do these look like they're symmetrical? They kind of look like they are, because you got one going up, you got one going sideways. It might be. Let's find out. Let's look at the blue one's vertex. So right here, that's at -3. 0, -3, right? The green one's sideways vertex is at -2, 0. Now, if one says -3 and the other vertex is -2, that ain't right. So let's count it. Ready? So from the blue one's vertex, it goes up 1, 2, 3, and it goes left 1, 2. Do those match? No. You can already tell it was close, but it's one off. So it's not symmetrical across y equals x. Therefore, it's not an inverse. So 4 was no, 3 was yes. Okay. Now, what you're going to do is make sure your name's on it, and every day has an objective and a date and a warm-up. Pass it to the front, and we're going to do an assignment. I'm going to pass it out while you pass that up. On your assignment, you're kind of doing what we did on the warm-up. You're verifying if it's inverse. I'll be back.